Good afternoon. Hello to everyone and welcome to our first webinar as Turkish Wind Energy Association. My name is Tuna Güven. I'm the board member of Turkish Wind Energy Association and I'm the Deputy General Manager of Borusan EMBW Energy. In today's webinar, what we are going to discuss is that in global scale, why is digitalization that critical for wind and renewable generation? What is the meaning? What is the role of digitalization for wind and renewables? And what has COVID made visible in this sense? With me today, I have three guests, and I'm delighted to introduce you Rosa Gindele, who is the head of analysis and optimization at RES Group UK, and Charles McLuckie, who is the control center manager at RES Group. Hello, Rosa. Hello, Charles.
Hi.
Great to be here with you today. And you are both in Glasgow right now. How is the situation in there?
Yeah, I think things have been improving. We've as far as coronavirus, we've got very few cases now and things seem to be being managed. So that's good. Everyone's still being quite careful. But yeah, and it's lovely sunny weather today. So
very good.
All happy.
Very good. Istanbul's also okay. What about you, Charles?
Yes, we're the same. It's been quite a success for us. We've managed to sustain our services and whatnot. So, and we had a real opportunity to test some of our digital systems, and that's proven to be a real success for us.
Yeah, you are right. It was a real opportunity, and also I'm delighted to introduce to you Santiago Lopez. He is also with me today, and he's the global director of Asset Management Services of UL. Welcome again, Santiago. You are in Spain in Pamplona region. Nowadays, under this staggering COVID situation, how is there?
Thanks, Tunabe, and thanks for inviting me to participate in this webinar. Spain is kind of going back to the previous stages due to coronavirus. We managed to control, let's say, the virus within the population. But now summer is back, kind of government opened the borders for the tourists during summer season, and there are some new cases. We believe it will be recovered and will be okay by the next following weeks. Thank you, Tuna, for asking.
Thank you. I hope we're going to cover very soon. Just a few words of housekeeping before we start. We are all working from home, and if there is a technical issue, please bear with us. And there is a translation right now, and there are two channels, Turkish and English. For Turkish, you should select Korean section on the list. I should say also in Turkish, bizi Türkçe dinlemek isteyenler Kore dilini seçmeleri gerekiyor.
For those who are willing to listen to us in Turkish, you have to select Korean.
Dear viewers, we are going to elaborate on this topic around 60 minutes together with my guests. And afterwards, there is going to be a Q&A session for your question around 20-25 minutes. Not only questions, you can also share with us your insights, your thoughts by using chat screen. Also, you can connect via video and your audio. And please submit your questions as we go along, and I'm gonna try to address as we go along as much as I can. Yes, let's start. As we all know, as an impact of COVID-19 in global scale, we suddenly found ourselves in lockdown, some daytime restrictions, social distancing the most loved ones, for our kids, teleschool for them, virtual meetings for us. It is unprecedented. It is a historical shock. This is how I can describe the impact of COVID-19 on our lives and as well as on the global system. Of course, these were all done to protect our health. But meanwhile, under these staggering conditions, some of the sectors who have digitalized beforehand have reacted very agile and shifted their people and their business to the home office immediately. As a conclusion, we saw that digitalization both protected their employees and business from COVID-19 impact to the maximum extent. In other words, digitalization boosted resilience. We experienced a very good example of this digitalization resilience coupling in wind energy sector so far. I can say that wind generation in global scale is almost not affected during COVID-19. Digitalization was one of the key drivers of this resilience of wind plants, because wind power plants are places where digitalization is used quite intensively on a global scale. For instance, remote management of wind facilities via digitalization, digitalized infrastructures without having people in the facility, those are already existed in the sector. And numbers prove this. According to the latest Global Energy Review 2020 of International Energy Agency, one field was not down is renewables. And renewables was actually the most resilient of all of the fields out there, and actually a little bit increased in first quarter of 2020. And global energy demand declined by 3.8% in the first quarter of 2020. Global cost was hit the hardest, falling by almost 8% compared with the first quarter of 2019. And oil demand was also hit strongly, down nearly 5%. This is the reason behind we choose this topic to discuss today with my guests. Yes, I would like to ask Santiago first to you, because you and your company is one of the experts of digitalization in global sense. How this resilience of wind plants, renewables achieved during COVID-19? Could you please tell us that? What does your company exactly do in wind plants in that sense?
Thanks to Nabay. Please allow me just a couple of minutes just to explain a little bit what's UL and what it does globally. Okay, UL is a company formed more than 125 years ago, and actually is a company where digitalization is part of the DNA of the company. Actually, the first computer was certified by UL more than 35 years ago. UL entered the renewable business by acquisition of different companies globally, especially the David-based German company, where I was part of it. And in the last years, we want to become, well, UL is becoming a global leader, not only in renewables, but in the digital transformation of the market. Next, please. Just to give you some reference numbers globally from UL, UL operates in more than 140 countries nowadays. We have offices, let's say, in every continent. We are a team of more than 500 subject matter experts on renewables. And just to give you an indication of how digitalization is taking part in UL world, between all the services I will describe later, all the possibilities, we are providing services in the digital world of more than 70 gigawatts globally. That means thousands of turbines, and you can imagine. Next, please. This is something I wanted to share with all of you, because digitalization sounds really good. Everyone talks about digitalization nowadays, but this is the real life of a wind farm. As you can see, there's tons of data, there is security concerns, there is productions, there is cost, there is fleet, different turbines technology, markets, policies. And you can imagine all these connections and interactions, and not only a country level or a wind farm level, you can imagine even a worldwide level. This is one exercise we did some years ago, actually it was 3 years ago, where we tried to connect all the dots and trying to see all the interactions. And basically, the main idea is to how digitalization and working remotely in automatic manner can improve basically what everyone is looking for. That is, reduce the cost of energy and thus improving the return of investment of every wind project. Next, please. And this is how Joel started this trip. 3 years, I said, 25 years ago. In the last 3 years, it was what we call the performance revolution. It's like a pyramid. We're starting from the basis, from the foundations that everyone's noticed to have data, proper data, integrity of the data, harmonization, and get rid of redundant databases. We have same database worldwide, always, so we normalize everything only one place. It's called RAMP. I will explain you later. Once we have a reliable data of any wind farm worldwide, we move to the next level. That's what we call the analysis of the data. So not only have the data, use advanced analytics of the data. That's what we call SaaS. It's a software as a service that we do and we provide to our customers. These are the basics to do what we call advanced analytics, and is the basics to start to do what is called predictive models with the data. So basically, the software and the algorithms start to be intelligent. We move to the next level in the last years, and we go to the control, and we get to the tip of the pyramid, what we call the smart energy control center. So basically, it's a fully automatized system. It decides by itself. It can be manual handling as well. As you can see, you have the advanced controls of the turbine, switch jars, and everything. I will show. You have automatization. Most of we recognize that 85% at least for all the tasks done from a control center can be automatized. And at the end, it's a topic now everyone is using is what we call artificial intelligence, where we implement our algorithms and we use it to get to move from proactive maintenance to predictive maintenance.
Very good, thank you. And these are all the applications and infrastructure you have at global scale. In coming questions, we are going to touch maybe more Turkey-specific issues. But before I jump there, Charles, you are the man in charge with that control center in that RES UK. I would like to ask same questions to you. How was this resilience of renewables achieved during COVID-19, and what do you do exactly in the wind plants in terms of that?
Yeah. I'll try and paint a picture of the model that we apply to allow us to achieve that distance managed model, if you like. Yeah. So currently, in terms of our portfolio, under management in that form of model, we have around 2,300 megawatts. And that portfolio, it's spread across all of the technologies that RES consider to be critical to a low carbon infrastructure. So you can see that includes wind, solar, storage, and also transmission systems as well. So breaking that down, we have around 65 wind farms under control in that form at the moment, which equates to about 820 turbines. And also the associated balance of plant infrastructure for those assets as well. That makes up roughly about 1,500 megawatts of our portfolio alone. So the vast majority of that does come from wind within RES. But we also have about 53 solar sites as well that we manage in that form, which equates to about 700 megawatts for our portfolio. We have 6 offshore transmission systems based in the UK that we look after for clients as well. These are the transmission systems that bring the energy from some of the key offshore wind farms in the UK. And we also have 5 battery storage plants, which equates to around about 75 megawatts. Next slide, please. So our current model, which revolves round about a centralised control location, it was established in 2014. So the drivers for establishing that were really to develop a sustainable model that could support RES's asset management offering. And to be honest, it was the developing industry standard. It's what clients expect. They now expect you to be able to facilitate monitoring and control of these assets 24 hours a day. So the old approach of looking after them during the day or establishing them and checking them once or twice a day really doesn't satisfy the market any longer. So that was 2 of the main drivers. At the moment, the market is predominantly UK focused for us in that sense, but we have over the last few years extended that to start to include France, Australia, the United States, Germany, and the Nordics as well. So we do recognise that there are real opportunities to apply in this model. It's the efficiencies that come with the economies of scale and controlling through a lot of the activities through a few individuals located in one location. So we're currently engaged in a globalization project where we're looking to extend these services out and ensure that we're developing the asset, we're developing the processes and the services that we deliver, and critically the systems that we use as well, so that we fully meet the needs of all the regions that RES plan or do operate in or plan to operate in the future. That's it for that one.
Control center is in Glasgow right now, right?
That's correct. Yeah. Can we have the next slide, please? Yes, yeah, as the Glasgow was strategically chosen to locate our control centre. We quickly recognised that, in terms of having a robust infrastructure in place, the first thing you need to consider is that your core hub needs to be secure and robust as well. So the Glasgow office has full redundancy in terms of power and comms systems. So the building itself is actually owned by one of the UK's broadcasting companies. So they have a solid infrastructure to support the building, and we take advantage of that. So Glasgow also, it's a facility that is manned 24 hours a day. So it allows us, it helps support our 24-hour manning requirements as well. So things like lone working and whatnot, it helps us facilitate some of those challenges as well.
Yeah.
In terms of staff, we have 9 operational controllers in total. They work a 24-hour shift. The facility never closes. We are open 365 days a year, and those staff we select them from varying backgrounds. In the past, we had realised that, or we felt that people with technical skills and backgrounds would maybe be a good fit. But as time has gone on, we've realised and learned that those that have good, strong systems and data management skills are really the ones that fit best for this position. So as you see, we take people that maybe have previously worked in high contact support centres, people that are used to dealing with multiple systems and dealing with large volumes of data and information and processing that. We've actually found that over time that those are the people that fit well. That system is used. We do have to supplement that. We do have site managers, so we have a team of individuals who can deal with the site-based activities where they are needed. But the general day-to-day activities are channeled through and dealt with by those 9 individuals. In terms of systems that we use, next slide, please. Can I have the next slide? In terms of the systems that we use to support this, first and foremost, we have what we call the smart dashboard. We learned over time that the SCADA systems that are generally supplied as part of the procurement of a wind farm or a solar site are in their own right very powerful operational tools. But in terms of being a sustainable monitoring platform, as your portfolio grows, it just isn't a feasible approach. So we use our smart system, which is a database for storing information, and we extract that data into the smart system, and we display it on what we call the smart dashboard. The smart dashboard is designed to direct you to the key information, only the key information, and only the key situations or changes and status that you need to pay attention to at any given time. Further to that, to support the smart dashboard, we do utilise the incumbent SCADA systems as well. We use those for detailed interrogation of information, so alarms, faults, running reports, that type of stuff. We use the SCADA system for that purpose, and obviously for the operations. But we don't have those systems running consistently. We will utilise them at the point of need only. Another system that we recognise, one that we established, was COSWIN. Now, COSWIN is, in essence, a computerised maintenance management system, primarily designed for works planning and works tracking and record keeping. But we have advanced the structure of that system so that we can use it for work control as well. Now that allows us the means of easily transferring information between different parties, setting out expectations. We use it for approval of works and whatnot as well. And ultimately, it's used as a database of records of maintenance and other types of activity that have taken place on the assets. We have grid interface systems as well. So in the UK, for instance, we have what's called Sentinel EDL and EDT. Now that allows us to communicate with National Grid on their chosen platform, and they use that to send us instructions on when we need to take some form of action. For instance, curtailing assets to meet the demands or to balance the demand and generation on the networks. And also in Australia, we have the Cromarty leg system, which is a grid dispatch system. And yeah, again, it's very similar. It allows us to facilitate the flow of information between ourselves and the grid managers. So I think that's probably a good example, a particularly good example of the importance of digital systems. Is, from Glasgow, we can readily and easily communicate with AMO, the grid operator in Australia, and satisfy their needs. We also use a system called Initiify. Initiify is an induction and competency tracking system. This has proven to be a particular success for us. We worked with Initiify, who are the manufacturers and suppliers of the system, and we developed a remote site access application as well. So basically, the people the technicians or visitors go into site can book themselves on autonomously via the application. Now, that equated to us saving something in the region of 40% of the calls and activity that were flowing in and out of the control centre. And we inherently found that people that were attending site in the early part of the day would have bottlenecks or rush hours, as we called them. You know, the vast majority of people are looking to attend site first thing in the morning. And that did create, when it was a manual process for us, it created a real bottleneck. By shifting over to a digital solution, a system-based solution, the system can cope and smooth that bottleneck out for us. So that was a particular success for us. And those are really the key systems that we use, and we use those to support the 5 core services that we use to facilitate this remote management model that we apply. Okay, that's all, Joe.
Do you have all messages for that? Or I think.
Sorry.
Okay, it's very, very interesting, and what I understand is that, I mean, there is so complex structures in digital infrastructures behind all this wind resilience, renewable resilience. In that point, I would like to remind our viewers, our audience, to ask their question. If they like, please use Q&A button on the down in the middle in the Zoom screen, not the chat screen, because I said chat, but it should be Q&A. You can also submit your questions as we go along. Santiago, I would like to ask a Turkey-specific question, but by the way, if you could answer, I would appreciate if you could answer as short as possible, as point as possible to that question, because it is very Turkey-specific. Before I'm asking that question, I need to give that information. Each wind energy plant in Turkey has a connection point to the grid. It means that each wind plant contains a high voltage switchyard. The reason why I explain this is that regardless of control capabilities of high voltage switchyard, national grid operator requires to have technical staff in the plant 24 hours, 7 days basis. In that point, in your systems, can you control high voltage switchyards and related equipment with your system? And also, as a connected question, is there an obligation, any obligation of 24/7 basis physical presence at the facility? And I'm going to ask same questions, Charles, to you afterwards.
Thanks to Nave. Yeah, the system allows you to control high switch charts, turbines, and all the grid point connections. Let me, before getting that, just explain a little bit more about the capabilities, expanding what Ray's presented. That I think it was great. You will move the whole conceptualization to create what we call the full digital assets lifecycle. Okay. So we fully have detailed the whole concept from the concept of the wind farm up to the operation and maintenance. All of the software are available and unique by under the same access. So for the customer, it's only one software, one connection point, and he can access all the different aspects of it. I will focus now only on the ramp and the last part of operations, and just to explain a little bit the capabilities you are asking to me. Next, please.
Okay.
So if we go specific to the ramp is the software that is the umbrella that covers all of the digital wind farms I explained before. SaaS Rapid SaaS software as a service solution that you will provide to our customers to monitor and to control their assets. Not only wind, it can be solar, we have hydro as well, okay? And it provides customized solutions to the owners, O&M directors, asset managers, and investors. And the advantage and the key differentiator is that advanced analytics and the portfolio insights of it.
Mhm.
I will go in details for the next couple of slides. Next, please. Here is a screenshot of all the sites in operation. This is just an example. Here you are seeing 26 sites globally, and it's very clear which are the problems, which are the information, alarms, and everything. And from this site, you already can start to control manually some of the aspects of the wind farm. But going to your specific question, to Navay, I will next slide, please.
Yes,
So this is a high
voltage scheme, right?
Chart from a specific wind farm. The question is very related to the legislation you need to comply with. In Spain and in Europe, basically most of Europe and worldwide, I will say, is the technology is very proven. It has a long history, and the legislation allows not to have 24/7 people on site. I mean, the systems are fully capable, and they are proven technology nowadays. They're fully able to work unmanned and in remote, and by certain algorithms and controls. There's no need for to have a human presence 24/7. Saying that, wind farm used to have small teams of maintenance, and usually the requirements on the contracts and the legislations and the grid operators is to have a minimum time to respond to those ones. The system includes as well not only the next please, not only the control of the different aspects of the wind farm. It provides two additional features as well. One is what we call. Can you move to the next one, please? It will be what we call the work orders. So from the same place, no need to change software or anything at all. You can assign works or to assign tasks to specific team members, and everything is linked and connected to alarms and everything, or to the actions taken. This is a database of knowledge as well to provide advanced making decisions in the future. Next, please.
I have a question in that point. That digital inspection platform, are those applicable for also the predictive maintenance purposes?
That's correct. Those are the basis to have enough data to be able to, your algorithms to be able to learn and improve. Basically, the system, what it does is learning by itself every day and correlate by itself every day. So in the long term, basically day by day, hour by hour, the more data you have, the less uncertainty you have in your predictions.
Okay.
And the last bit of the software provided as well is what we call part of the software is the digital inspection platform. So you are not able to control, you are not able to assign work orders, you are even able to assign checklists and inspections or whatever task to be done on site. If you go to the next one, please, just to complete this part. All of these software is accessible by an app or via web, okay? So it doesn't really matter where you are, which part of the world. People don't need to travel. You just need to download the application from the Google Store or the App Store. As you can imagine, as is proven here, can you imagine the advantage of this? There's no need more to delays to administrative tasks. There's no need more for paperwork. And basically, the team digital manage the whole system, the entire process from the setup of the project up to the final reporting to the customers. Again, this gives the availability to our customers to have real-time data what's going on, not only on the operation and the inspections and the maintenance done on their turbines. Next one, please. And as I said before, it's so easy to use. You just need a connection or data available. You just go to the App Store, Google Store, you download our app. It's very easy setup. You just need username and password, and then basically it's a full platform to tell you what to do, the checklist. You can attach information. And regarding the question before about the advanced machine learning, artificial intelligence, the next release will have even machine learning techniques. So basically, a person who will do a specific maintenance on a specific place you will have visual ads as well on the platform to be able to understand, and the manuals and everything, and as well video connection to any part of the world, so any support needed will be granted straight away.
My last question was, is there any obligation regarding the physical presence?
No, there's no legal obligation to have physical presence. You only have an obligation regarding to the grid connector to have a minimum time of response.
Mm-hmm.
The second one will be that, at least in Spain, you are obliged to communicate to the grid operator how much amount of energy you're gonna input into the system in the 24 and 48 hours. And if you deviate 3% top and down, you will have some penalties on top.
Okay, thank you. Yes, Charles. Same questions to you as well. Can you control the high voltage sites and obligation of the physical presence?
Yes, yeah, we certainly can. Can we have slide 5, please, as well, just to support? Yes. Yes. I suppose just to caveat that is to say that, yeah, we can control the assets, but to a point. What we generally find is that your capabilities are generally limited to what would be normal operational capabilities. So, for instance, opening, closing switches and circuit breakers. But what is considered to be more advanced applications, such as applying earths and whatnot, would not generally be covered under the automated systems at all. Also, to supplement this, we also see that in many cases you would have designed in some form of auto reinstatement scheme on many of the wind farms. These are designed to enable a re-energization after a short outage of some form. These can extend to a few outages for a few seconds, just a blip in the grid that needs a ride through, or to maybe outages that last somewhere between 10 and 15 minutes. What we also realise in our market is the decision to develop these assets and how capable they are tends to be defined by some form of risk analysis. So, for instance, maybe on larger wind farms or wind farms that have a particularly onerous power purchase agreement terms that may expose them to high losses or high penalties, you may, as a mitigation, design in some additional redundancy or some form of additional capability that would allow you to mitigate against those risks as much as possible and reinstate the asset as quickly as possible. But generally, in terms of your obligations to have somebody on site constantly, no, that's not something that we would commonly see. A bit like Santiago had suggested, there is often an obligation, whether it be a contractual obligation to your client or some form of obligation to the grid operator, that you would have technical staff available 24 hours. Those would, where possible, take advantage of the digitalized systems and try and reinstate wherever possible. But as a fallback to that, a general expectation would be that you could have people on the ground within 24 hours. So our experiences are that particularly the HV networks are fairly inert, they're fairly stable. You know, the activities or the need to operate them is the few and far between. You know, it's not a very common requirement. So, in terms of the economies, having people on site, it just would not make any sense whatsoever. And what we have seen in the UK is almost an industry develop behind this. You know, so we've got organisations that are strategically positioning themselves throughout the country so that they can provide services within those 4-hour defined periods. RES, for example, we will take advantage of a mix of both internal capability where we have people strategically located, or we may subcontract that as well, just to help you to meet your obligations to the contracts. I could state at the moment I am not aware of any assets at all that we look after that would in any way require 24-hour staffing on site. Okay.
Are you talking UK specific or in global scale?
Yes, global scale. Global scale. Yep. I'm not aware of any of our assets in any of our markets where that would be the expectation.
Yeah. I mean, fantastic. Yes. And Rosa, I mean, UL and RES has both operations branches in Turkey, so that you are the head of optimization and analysis. And when you look at Turkey, what is your specific advice? What do you think that what needs to be matured in Turkey in order to expand all this infrastructure, that digitalization types, blah, blah?
Yeah, I mean, I can certainly tell you what RES has found to be key to the expansion of infrastructure, and probably your listeners can judge very well where kind of Turkey needs to develop a bit with that. I mean, first and foremost, with remote monitoring and control, you need a really robust connection with site. So firstly, you want to define and rationalize that total system and model that to decide what information you really need from each part of the system. So for example, I think Charlie was saying earlier, a SCADA system from a turbine manufacturer, they're very useful for a site manager, but they don't make a sustainable monitoring tool when you have 30, 50, 100 sites to look at. And with the robust communication, you also need very good operational technology, we would call it. So being able to use the data from the wind farm in different ways. So by operational technology, I mean, for example, the computerized maintenance management systems, the historians for capturing SCADA data and forming database, and then also systems for showing live data or communicating. So actually getting those systems in place, and Santiago also talked about this, that is absolutely key to be able, company basis, you need to define what your key processes are, and then standardize that as much as possible to grow. As companies get more and more wind farms and other renewables plant on to asset manage, trying to sustain operations at a very high level requires a lot of standardization as the portfolio grows. And generally, you're always trying as an asset manager to increase your client returns and lower the operational costs. So digitalization certainly helps all that. But I mean, so in the UK, the government stopped wind subsidies quite quickly, and the wind industry had to adapt very, very quickly. And we found that as a company, we had to innovate to stay competitive. And RES has now sold subsidy-free wind farms. So I think you mentioned it yourself before, that actually when you set up those systems well and streamlined your processes, you are going to fare much better in whatever the market is. Either you're making more profit while the returns are very good, or when that starts to slim down, you're in a good position to do more innovation. And we did find, even with COVID-19 was another one where we had to innovate quite quickly, and we did a lot more. We did remote inspections, so we used live streaming in order to inspect condition of turbines. There are some absolutely fantastic pieces of software now that you can use. I know the control center as well was using some a kind of piece of software that's used in the gaming industry to set up kind of teams of people so that they can communicate as if they were sat together in the control center. So it's, I think, as in markets develop, industry develops, and kind of companies themselves develop, it's about standardizing, streamlining processes, and innovating, and that will put people in a good position.
Yeah, I mean, it is fantastic. I mean, because you are telling me about maybe tons of different kinds of digitalization applications, and they consolidate in a plant. And what is interesting, maybe for our viewers right now, most of the applications, we should say that most of the applications, they will exist in the market, in the wind sector, in the energy market. And if a company had invested beforehand, I mean, they act very agile to that. That's why I asked that question specific to Turkey. What is the roadmap for Turkey? What was your specific advice? Thank you, Rosa. And same question to you, Santiago. What is your specific advice? And you have the operations in Turkey as well as we have the branch. And what do you think? What do you say?
Yeah, actually, from Joel, based on our experience in Turkey, we really believe that the hardware or the infrastructure to run remote monitoring technology is already existing in Turkey, okay? The internet nowadays allows you to reach out from one region to another region in Turkey without leaving the home or the office. Existing systems, like the one I explained or my colleagues of REST, are there, and it's a question of people start using the technology. There are several aspects to have into account. I mean, the first one will be the technical aspect. Already proven worldwide, as you can see through the presentation. The safety aspect, and not thinking only safety about safety of people or safety on the infrastructures. I'm including cybersecurity as well. Nowadays, it's very important of the safety regarding remote control, remote monitoring data, and there are proven technology going on for years already proving the market. The economic aspect of it will be explained later, but it's obvious. The COVID, as Rosa really well explained, hit us strong, and we need to reinvent ourselves and use the actual technology to be able for companies to keep working. And the last one will be the legal aspect, okay? The legal aspect is very country related, but if all the previous ones, technical, safety, economical, everything makes sense, the legal aspect just should be a follow-up of those ones.
Yeah. I mean, that legal part, I mean, it's, as far as I know, we are in Turkey, and I know some global examples is something else. And there is such a question in the Q&A part. Maybe in the Q&A session, I would like to answer that question. But what are the things? What are the points should be improved by the national grid operator itself in terms of regulatory perspective, in terms of technical perspective? But please keep that question in your minds, and then we are going to discuss on that point in the Q&A session. Yes, let's move out from Turkey and then again come to the global scale. All these we are talking here has, of course, a cost-benefit effect. It's obvious that. And yes, we are talking mostly about COVID-19 conditions, but especially for the post-incentive period. I'm talking about the period after the expiration of the feed-in tariff. The sales price decreases and market price is quite low, and wind power plants become more difficult to be competitive. Okay, so to what extent does these practices reduce the cost, in total cost. What is the experience gained from real examples? We can start with you, Rosa.
Yeah, I mean, efficiency is absolutely, in my view, the key to competitiveness. You know, having a sort of estimate, you know, having 24/7 technicians on site, we think could probably increase the cost of operations by a factor of 4. It's very expensive. So remote monitoring, remote control is really important. I mean, in addition to kind of controlling plant remotely, for RES, the performance monitoring remotely is very important specialism as well. It brings a huge value to our clients. And what I mean by this is really analysing the data from the wind farms in order to increase the efficiency of the wind farm, and therefore the production. So, you know, for example, if you're using the data to understand a problem before you send a technician, you're more likely to get it right first time. And you can fix issues remotely. So some issues are just software, or for example, you might have to use the data, find there's an issue, talk to the grid operator or someone else. You can do all that remotely without going to site and get things resolved very quickly. And also through condition monitoring, such as vibration condition monitoring or temperature monitoring, you can actually prevent component failures. So you can reduce the cost of repairs, and you know, you've also got a kind of environmental and safety aspect of this. You know, you can increase the safety on site, reduce the environmental impact of operations through travel, all that as well. But fundamentally, you know, you're all helping to increase the profitability of wind farms, which is the kind of key to success in the market. So if you could go to the next slide, I can explain a little bit more about a specific way we remotely monitor the data. We analyze operational losses. So that's losses which occur while the turbine is still running. And as you can see in these examples, just because you have very high availability of the turbines, it doesn't actually mean that you have a maximized production. So the first example is when a technician incorrectly activated a noise curtailment mode. You know, something like this, it's when the turbine is operating at full load often, or very high load. You know, so it's about £200,000 in a year or something, just on that kind of very small wind farm. It may seem like a small amount, but these things really add up. The second example is where there was just a bug in the wind farm controller, and the first turbine on the string had sort of 1 to 2% reduction on the top of the power curve. Again, it seems like a very small amount, but it adds up a huge amount. And those kind of things, you know, there's no reason to be losing that. It just takes some you know, intelligent use of data to identify these things completely remotely and resolve them. And we've seen on the next slides, I've given some information. You know, we've actually had this assessed independently as well. So RES commissioned an independent study, and because of the management processes and the experience we have in the tools, such as remote performance monitoring and condition monitoring, the wind farms managed by RES actually achieve an additional 1% output compared to the industry standard. And 1% might feel like it's a small percentage, but actually, you know, most people on this call will understand how much that's worth in real terms. You know, it's instead of having 97% production-based availability, you've got 98% production-based availability for 30 years of the wind farm. You know, it's absolutely huge. It increases the value of projects by, you know, millions of pounds, or yeah.
As an absolute number is one is so small, but it depends on all how you calculate that one.
Yeah, absolutely. Yeah, and I think, you know, a 50 megawatt site for 30 years, 1% is actually, yeah, a huge amount, and certainly something that, you know, if you think how an investor or client might respond if they thought they were, I don't know, 0.5% under budget or something, you know, that would be a huge deal. So yeah, it does make a big difference, and all of that helps. You know, the more we can do like that, that helps a site to be run efficiently. That's all helping wind farms to be competitive in kind of subsidy free or kind of more harsh market environments. So it's definitely been a huge help for us.
Yeah. Okay, thank you, Rosa. And Santiago, what is that cost-benefit effect of all the digitalized systems from your perspective?
Yeah, actually, I bring a couple of examples just to make things clear, right? People like to have the clear numbers and everything. But before starting, I think it's the right moment to talk about this. We all know that the PPA mechanism or the local content mechanism in Turkey, the deadline is by the end of this year, right? So we all have uncertainties of what will happen for the new capacity installed for the following ones. So again, digitalization and improvement of return on the investment is a key aspect here. The first example I want to show you is by means of using all the different tools similar to the rest explained before and everything. It's a specific wind farm. Just to give you a number here, it's 62 turbines, total capacity of 49 megawatts. And just by automatizing the research or some specific alarms without needing the technician go in the turbine and reset or click on the remote control center, we reduced from 1 year to the other more than 90% the total hours lost per specific turbines. That means a successful rate of more than 81% and a total savings only in 1 year, just to give you an average of 43,000 euros. If you multiply by 20, as Rosa was saying before, the numbers are huge, right? Next, please. The next one is slightly different. It's regarding with the uncertainties you mentioned before as well. And this is very related with the pool market. I mean, after the PPA mechanism expired, and Spain is suffering this is long time, same as UK, okay, you are going to the pool market. So sometimes the cost of producing is higher than the benefits you are getting to ingest on the net, right? So by just applying a very simple rule in the control center algorithm that control the turbines with the forecasting and production and everything, and the rule is easy. Just stop the turbines or the wind farm when the pool price is less than the marginal cost of operation. Just by doing that in this specific wind farm during 2 years of operations, the direct saving was 19,000 euros, sorry, 7,300 savings, and a total saving cost of 2 years of 92,000 euros. There are two basic examples, but this gives you a clear view of the potential of by few things you can adjust and automatic control and apply remotely, again without being on site, the big numbers you can save and the things you can be able to do. And once you have the data, once you have the normalized data, while you understand the rules of the game, it's just a question of really program and do the software work for you.
Yes, those are very, very important findings that shows us the low-cost generation of wind energy is one of the main drivers of that resilience, which I showed numbers at the very beginning. The people part is one part, because you send people their homes, you digitalize your business, and then nearly zero effect, you go ahead your business. It's some parts, and altogether this that cost part creates a real resilience. This is what I understood so far. Yes, at this point, before we jump to the Q&A session, we spent 60 minutes so far. So far, I would like to thank for all your comments, all your insights, all your explanations. Before I jump to the Q&A session, I would like to add, I would like to tell a little bit about global warming side of COVID-19. COVID-19 has a drastic effect. We know it. Presumably, this effect unfortunately continues, and most of it are negative ones, such as health problems, bans of public gatherings, some macroeconomic impact, blah blah. But nature has had a real chance to take a breath and recover itself for decades, because people stayed at their homes, lowered their activities that would increase carbon dioxide emissions. To give an example, they couldn't use their vehicles or travel by plane. Since people were staying their homes, electricity consumption fell. So fossil fuel usage decreased significantly in the power generation and in our daily life. Remember the numbers which I gave at the very beginning. And as a conclusion, nature took a real breath. I really find it very important and striking, because people have experienced that how effective renewable generation is to overcome the climate crisis. The effect of generating electricity from wind and sun, those are the main components of the renewable, let's say, instead of fossil fuels, has become very striking than ever before right now. On the other hand, it became more visible for us how important the acceleration of electrification plays a key role. We can say it has a chain effect. As fossil fueled vehicles leave their places to the electrical vehicles, as natural gas and fossil fuel heating systems turn into the electric ones, and electricity consumed there is provided from renewable sources, I believe nature will be even more recovered. From that perspective, I believe that it's a renaissance and it's a milestone. At the bottom line, COVID-19 showed us this trio of renewable energy, electrification, and digitalization are the three main pillars, main drivers of overcoming climate crisis. This is what I believe. Yes, we have questions. I would like to direct to you, to my guests. In question 2, I connected one question. What should be improved in Turkey by the National Grid Authority, or from the regulatory perspective? This is one of the questions. Who would like to answer that? Santiago, Rose, or Charles?
I can jump if you want. I think the government and the legislations need to be used and served to help develop the economy and create work, jobs and everything. So it's just a question to really develop the legislation and the laws in a way that allows us to implement more and more digitalization and by means of advanced softwares and this kind of stuff we presented today. I mean, it doesn't make sense to invest money and effort and time in this transformation when at the end of the day you need to have 24/7 guys on site.
Yes,
I agree. Yeah. Just create an environment that investors want to be involved in. Definitely, that's like we were it's suggested in a few of my answers as well that the requirements and a lot of the existing assets that we manage are defined by the risk, and the need and whatnot, So they need to be what you need to deliver needs to be attached to something tangible and sensible, I would say. So, yeah, just broadly stating that this is what you would like is probably not conducive to an open market. Yeah.
I think fundamentally, what's needed is safe systems, safe for people, safe for the plant, and a robust network. And so I suppose I would say that, as with everything, things can be delivered in lots of different ways. So it's just about exploring what regulation or what kind of strategy can achieve those end goals, rather than necessarily putting in something that you think will, but might have an adverse effect, such as actually closing the market down.
There are questions here. I'm going to try to direct you that questions as much as possible, but there are some questions. Also, you can answer some of them afterwards, because those are all submitted here. By the way, for our participants in Zoom, you can also raise your hands, open your video, and by your voice, you can ask your questions. Not only questions, you can share your insights, your thoughts regarding our talks and our topics. We are all open for that. And there are two questions, Charles, to you. Questions like that. You have mentioned that you have 9 staff in remote surveillance center. Is there a turbine limit for each operator to watch over? Are they just managing alerts and escalating the issue, or do they also reset and intervene the turbine to fix some alerts?
Yes, yeah, we do the resets and whatnot. So it may be that the arrangements, the want and maintenance arrangements that are in place for the particular assets dictate what we can do from the control center. But wherever we have that opportunity, we will carry out fault resets and whatnot as well. Yep. Mm-hmm. Yes, we have some assumptions, so we, in terms of our staffing levels and our capacities, we build some assumptions behind different types of assets, and we model that as we expand, so we can add, for instance, we have onboarded another 3 wind farms that will take a percentage of available resource off of our staff. So we can see where we start to consume and potentially where the staff will become overconsumed by the amount of asset. Yeah.
Yeah.
Yep.
Okay. Thank you. And there is a hard question right now. You have to be ready. Do you think this could cause unemployment and increase unemployment rates going up, or create even more new professions with new skills? All these digitalization applications in the renewables and wind plants.
From our experience in UL, we believe digitalization will create new opportunities for people. It's not a question of the lose jobs or not. Jobs just will change the job descriptions and the way to do things. Clear example. 20 years ago, you have tons of analysts just drawing by hand. Nowadays, you do it by computer, and all those people are still working in the industry. So it's not a question of losing jobs, it's just to do things differently and leave the people to do things more interesting than learning new things, basically.
Mm. Yeah, I mean, in my team, I've done this for sort of 4 or 5 years. I've managed a team, and in that time, the numbers have tripled. Just in my team, you know, Charlie's is the same. It's about jobs changing, and you know, we have seen growth in the industry. The important thing is that the industry can grow, and you have to be competitive and you have to be agile to enable that. You know, the worst thing is if you say, you know, nothing will change and we won't digitalize anything, and actually then the market goes away. That would be the worst thing you can do, because then the people who are in the market already then lose their jobs. So the important thing is to maintain the industry and the growth of renewables, and the only way to do that really is to innovate and to digitalize, to do it efficiently.
So what I understood is that it's not that bad. I mean, it's not that problematic.
No, people are just doing different things. So my team quite rarely go to site. We do so much remote performance monitoring. Charlie's team, they don't go to site either. We still have people who do go to site. We have asset managers and site managers. We have subcontractors. We have technicians. You know, there are lots and lots and lots of different jobs. It's, you know, everyone finds what they enjoy and goes into different areas. But yeah, it's just different, I think.
So I spoke earlier about the evolving high voltage market in the UK. We, in the past, that was quite vibrant, and when there was a lot of heavy industry in the UK, and as the heavy industry declined, there was less and less demand for that type of service. The development of renewables, we're seeing that's igniting some growth in that type of skill set again. So that's another example where we are seeing, you know, a growing market. So yeah, there's definitely, I just see growth at the moment. I just see opportunities developing, and as Rosa says, we've seen our team grow by quite an extent in the time that I've worked for Res.
There is a connected question to your answers. What are the what kind of expertise, what kind of features in the CV, let's say, I should say, required for such works, for such digitalized systems?
I mean, I see that there are different parts of digitalization. One is what I'd call like infrastructure. So it's people who are able to develop the systems to get data off-site and into offices. Then there's more data engineering, which I would call about sort of getting databases in the right structures, being able to standardize data, that kind of thing. Then there's, I suppose, analysts who might look at that data and recommend actions. So they're people who have more understanding of the context and the engineering basis around it. And then there's teams of data scientists and software engineers who are finding new AI or machine learning ways to analyze the data. That's kind of where we see the different skill sets, and yeah, there's obviously a lot more probably.
Yeah.
I think I touched on the fact that we have learned a fair bit about the skills that people need in the control centre. We maybe assumed that those skills that were deemed as relevant a few years back weren't so key in this developing market. So, you know, we have now turned to those that are competent and capable to use these digital systems and are comfortable really in large amounts of information and whatnot, you know. So, and then when we move to the technical elements, we just find that we need to be much more process driven rather than competency driven. So it changes yeah, it changes who you are looking at as well in terms of filling these positions. We rely heavily on our IT support teams now as well, so we're seeing a substantial growth there. So, you know, as we use more and more systems that become more critical to your operations, they need to be as robust as possible. And yeah, we rely heavily in Glasgow on our IT support teams.
Yeah. And there is a comment regarding this discussion from Martin Nilsson. On your current question, I know that, he says, I know that one output for EDF in NA have hired more technicians as they are now able to make them more efficient with the findings from analyzing the data. This was linked to our prior discussion.
Yeah, I can see that definitely. You know, when you look at the data, you're sending someone with the correct equipment, you're sending someone already with the parts that they need. And, you know, it's not so much, there's a certain amount that any wind farm can sustain. You know, it's not, you can't go over that amount because then it's not cost effective and there's no profit. But the more you can, in some ways, the more you can streamline that service and make that process very clear and easy to follow, you can actually have more room for bringing more people on because you have the money to do that. When your processes are very inefficient, you just, you know, you have to work with what you can afford. Yeah.
Yeah, one small comment on top of that. I totally agree with what Cole is just explaining here. Maybe you went one step further. So we already moved from a process-driven company to a really data-driven company. So the data was telling us what to do, really. We get rid of some processes somehow because it was a stopper for us in trying to do innovation. Of course, you have to have processes in place. So don't get me wrong, guys. I fully agree with you. You have to get processes, then you automatize that and whatever. On the same time, you need to be more agile, as Rosa was explaining before. So you need to have this combination of people, as Rosa was explaining, probably as well some project management skills there to really put together the team. That is difficult to really to make the people go in one direction. Probably some BDMs or business development managers as well to really understand the market and the customers and everything. But again, and I think Res is on the same stage, probably what we are doing by this digital transformation is becoming a data-driven company. So we don't rely in opinions anymore. We rely on facts based on data.
Yeah, this is called data-driven.
Yeah.
Also, we see the same thing in our portfolio as well, in our company. I mean, the key thing is more you analyze, more data you have, more to-dos you have. So you know where to look, where to touch. It creates an efficiency, that's correct, but it creates lots of additional things. And that things, when you touch all that things you get from that analysis are very valuable, because that's you know, when you make that analysis, when I touch here, I'm going to take a value. So it creates a new world, let's say. And we talk a little bit about markets. We touch a little bit about markets. As a last question, I would like to take that question. Can the digitalization increase the competition among turbine manufacturers to target to secure O&M services to another brands machines all over the world? There is such a question.
You gonna go, guys? Or?
Yeah, I mean, I would say that so the question's, can it increase competitive within turbine manufacturers? Yeah. What we're seeing is manufacturers really are moving with this as well. They have big data centers, often cloud-based data centers, and they are using that information. Absolutely. For an asset manager, the powerful thing is that when we have the data, we can have that conversation with OEMs. We can have that conversation with O&M teams. If you are blind to the data, then they can see it. They have a completely different requirement. So for us, it's our clients we need to protect at all times. It's the owners of the wind farms, if it's not ourselves. So we have to make sure we're doing getting the most out of the wind farms for them. The turbine manufacturers or the O&M contractor, they have to manage multiple sites and different, across the globe, and they're not always aiming to absolutely maximize the production of the wind farm. They're aiming to balance the risk across their performance incentives or their warranties. So it's important for asset managers to have that data to enable a conversation with O&M contractors. But certainly, as far as I can see, all the big turbine manufacturers are using that data much more. But we just have to bear in mind that they may not always be aiming for exactly the same thing as we are. And that's why it's important for us to also have the data and to be able to critically evaluate that and work together as a team to improve performance.
Yeah, I agree. I think it's using that data to be able to influence them more in the future, rather than being proactive, being involved, taking that data and using it to explain to the client what you need, or maybe try and influence the supplier to what you need, what you need from them ultimately. And who knows, maybe in the future use them to restructure the agreements that you have in place with these organisations to make them more competitive and focus them more towards what the client really needs and what will really benefit the client.
Yeah.
It's true that digitalization on OEMs is happening worldwide. Actually, my experience is the last 5 years I'm working on this. Is for me, it's like a digital vortex, right, on the market, and everyone is affected by it. The only question is how far or how close are you to the center of that vortex. But doesn't really matter if you want to go, no? As I was explaining and you to Nabay before, you need to move to this direction. Otherwise, you will get out of the market straight away. So the answer is yes, everyone is going to that direction. Data is important, but integrity of data is key as well. And of course, to have the expertise in-house to be able to understand the results of those data. I saw crazy people looking for crazy interactions between, I don't know, gearbox was high temperature, there was raining, and it was Sunday. Your gearbox will break. Come on, guys. So it's to have the knowledge, to have the data, and make sense of it. One additional comment I would like to say that is it will be nice eventually one day, as far as I was explaining, that the OEMs open somehow to the rest of the market and work as a team, not only asset owners and our companies or whatever, but really to become one full team like other industries, like, I don't know, aerospace, airplanes, all these kind of things. So, for example, you do a root cause analysis based on data, and the results are published, so everyone knows from that. In the wind industry, is still this kind of hiding, not hiding, but keeping the IP properties and these kind of things. I think it will really make a difference for all of us if one day this happens.
Yeah, I agree that it's important to know how to use the data. And I think in some ways, I think the wind industry is has done very well because we have had the experience over quite a number of years.
Yeah.
You know, Res itself is 38 years old, I think, this year. So we have been able to learn how systems work, and you know, we know so much about wind turbines. Even though they have evolved, we've learned from the basics. And now, but we're still young enough to be agile and to take on the learnings from, you know, that innovation gives us. And I think other industries do to a certain amount, but I think in areas like oil and gas, or sometimes it can be areas like condition monitoring in aerospace, or you know, remote inspections in oil and gas, we can, as an industry, take on all these lessons that we learned, and understand how to use data to reflect the real world situation. Like I mentioned before, you know, you have your data engineers on one side, you have your data scientists, but statisticians still need to know how it relates to a turbine gearbox. And you know, you do see people kind of think that there's some silver bullet to just you know, you kind of click this button and it will tell you exactly what to do on every turbine. But diagnosing a problem on a wind farm, you know, can sometimes still be tricky. It's important to know exactly what's happened before you implement any kind of site visits, and therefore, you know, you need to make sure you're understanding what your data says. I think that's a really good point.
Yeah. We are getting to the closure step by step. It was a fruitful discussion. Before I close, I would like to ask you, would you like to add something regarding all that discussions? Please, your last words.
Yeah, just to say that, you know, don't be afraid of the change. Engage in these systems. It doesn't have to be wholesale changes either, as we've seen for some of the figures that were shared today. It tends to be an accumulation of small improvements, small gains made here and there, you know, and you should always strive to seek those small improvements out. So, yeah, don't fear the change. Go and find the opportunities.
Yeah, I would say, you know, we talked a bit about, you know, innovation in the face of COVID, or innovation for the industry and things. Innovation really is a cultural thing, and that's what's important to bring into companies now, because it will, you know, it will mean that, however, you know, none of us have a crystal ball. We don't know what's happening in the future necessarily. We don't know if they'll, you know, we didn't know the pandemic would happen. We may know some regulatory change will happen, but we certainly can't see everything. But when you have innovation as part of a culture and a mindset in a company or an industry, you are more prepared for these unexpected things.
Thank you, Rosa.
Yeah, definitely, guys. On top of that, we said it's a question of it's a proven, it works worldwide. It's just a question of really make things happen. Chris says very well, don't be afraid of change. Change is good. Don't be afraid of digitalization. Digitalization is good. It will allow us to do probably new and more interesting things for everyone. It's a proven technology. It's international standards as well who really rule this worldwide. It works globally nowadays. We are not talking about boundaries anymore. I mean, it's a global world nowadays. It's the only way to really be prepared, as my colleague says, to be prepared for the unexpected. I mean, COVID was unexpected for us. We're still learning, but who knows who's in the future. So the better we are prepared now, the better for us for the future.
Thank you. Yes, Rosa, Santi, Charlie, thank you very much indeed for the valuable insights you shared with us this afternoon. And also I would like to thank all participants here on Turkish wind energy sector behalf. Ladies and gentlemen, thanks for listening to us today. Today we talked about a very important topic. We talked about how digitalization boosts resilience of wind fuel and of course renewables today. And this trio of electrification, digitalization, and renewables is a real solution for global warming. As a last word, please be demanding for renewables and safe. Thanks for listening to us today and goodbye.
Thank you.
Thank you.
Thank you. Thanks.
Thank you.